Hello, everyone. My name is Deepen Desai. I'm the head of security research here at Zscaler. I have with me Nirmal Singh, who's the senior manager, security research, and then Avinash Kumar, who's the senior security research in ThreatLabZ. So we have here today our research on emerging trends that we're seeing in malware downloaders that we've captured in Zscaler Cloud Platform over the past 2 years. A quick look at the agenda. We'll start with an introduction on what the study focuses on, what are some of the highlights we saw. We'll jump into how the overall threat landscape has evolved and what role does the malware downloaders play as part of the attack cycle. And then we'll jump right into prevalent campaigns that the team has uncovered over the past couple years in the cloud. So threat actors are continuously evolving their TTPs in order to target the end organizations. And what we're seeing over the past few years is almost all targeted campaigns now start with a downloader payload. And a lot of these downloader payloads are multi-staged. So it doesn't involve one binary resulting in the final payload being downloaded. It will usually involve several different payloads that gets processed before the final payload is served. The attackers have incorporated various anti-analysis evasion techniques into the stage 1, stage 2 payloads itself. That way they are able to safeguard the final payload from being detected by the security engines. Now, malware downloaders are often non-persistent in nature. Like I said, they will perform several checks on the target system, and the main goal is to download and install the final payload on the system. So in this research, we've highlighted several different trends that were captured in 2019 and 2020 timeframe. Now, if you take a step back and look at the overall cybercrime economy, it's basically a supply chain model. There are several threat actors involved at different stages of the infection flow. It typically starts with the initial delivery vector, where they have their own way of generating revenue as well. So typically compromised sites or botnets where the bot operators will rent out the infrastructure, phishing campaigns, malvertising, and the main goal over there is to get that user to click on the link or download the payload. The second stage usually involves some kind of exploitation infrastructure or a social engineering tactic where typically downloader and dropper payloads are involved. And these second stage payloads usually perform several checks before downloading the final payload, which could be a ransomware, which could be RAD, depending on the motive of the campaign. A targeted payload can also get served. So, like I mentioned earlier, we will be zooming into this section of the overall attack infrastructure. So a typical infection cycle starts with a mal spam, spammed email containing bank statements, shipping labels. In the current time that we're living in, there's a lot of COVID-19 related lures that are being used by the bad actors. The bad actors are also leveraging, government financial aid related teams in order to send out the initial payloads via emails. Now, if the user falls for this payload, the malware downloader is actually set up on the user's machine. And these downloaders typically leverage social engineering tactic in order to convince the user to run the malicious code that's embedded in it. And they use several techniques over here. It could be as simple as leveraging an icon that looks like a PDF file on an executable, or leveraging multi-extensions, or it could be a document that is claiming to contain hidden message and requires user to click on the enable content. Now, what has happened over the past few years is these malware downloaders have evolved and included a lot of anti-analysis and evasion techniques. So they will literally fingerprint the system on which the payload is being executed. They will also fingerprint the network by communicating with certain destinations on the internet. And the goal over here is to make sure that it is indeed the target where the malware author wants the final payload to be downloaded and installed. So they verify that first before leading to the download of the final malware payload. So we collected tens of thousands of payload. I'll talk about the study approach, but when we looked at the distribution of various file types that were involved in these malware downloaders, a staggering 50 plus percentage of malware downloaders were document files. So that kind of tells that a lot of the attackers are now relying on using social engineering tactics in most occasions, as you will see in the campaign details. They're relying on convincing the user to actually execute the macro code, and then taking advantage of various obfuscation and advanced techniques. They're able to usually bypass the static signature-based detection engines. Executables were second most popular at about 23%, but as you can see, a vast majority of the stage one payloads are Office documents. We also looked at what malware families were involved when these downloader payloads are downloaded. And Emotet, Edi Loader, and Upatre were among the most prevalent downloader families that were seen in the Zscaler cloud when we looked at all the payloads hitting our sandbox in 2020. Now, many of these malware families are connected. For instance, you could see a downloader payload download Emotet, but the Emotet infection could further lead to one of the other malware families that you're seeing over here, especially things like TrickBot. We've seen several instances of targeted attacks where Drydex and TrickBot downloaders were leveraged by the bad guys to plant ransomware payload on the target networks. So a quick look at the study approach. We have done a large scale analysis on data set of tens of thousands of real world samples. Like I mentioned earlier, these are samples that were collected over the past 2 years in Zscaler Cloud. And we performed clustering of these samples using static features that we extracted. We also looked at some of the heuristics and behavioral similarities. So these majority of these samples were detonated inside our lab's sandbox. And based on the behavior similarities, again, we'll cluster similar samples, campaign level similarities, and we've outlined some of the campaigns in this research. So the review of malware downloader campaign case studies that you will see in the upcoming slides will try to talk about various obfuscation techniques that the cyber criminals are using to evade detection, a type of delivery mechanisms that are leveraged in order to plant the final payload. And above everything else, the level of evasion techniques and anti-analysis techniques that we're starting to see in the downloader payloads itself. And the goal over there is to safeguard the final malware payloads from getting detected by the security engines. So with that, I'll have Nirmal talk about the various active campaigns in the upcoming slides. Nirmal?
Thank you, Deepen. Okay, so the first case study that we will like to talk about, we call it Zoro. So this campaign was taking advantage of the COVID-19 related situation, and it was using email templates with the COVID related information. The threat actor that we attributed in this campaign was Vulvon. And so the main malware here was having multiple stages. The downloader was doing multiple stages of activity. And we observed the spike of this malware starting from March 2020 to April 2020. And the target industry in this case was telecom, finance, and manufacturing technologies. Yeah, so if you talk about the name of the malware, like how we came up to this name, so that is based on the config file name. And we observed that there are frequent changes in the stages of infection in this malware, but overall technique is same. One of the important things that we observed is that it's using GitLab to host the payload. And we also observed that it's getting more sophisticated over time. It's now using dedicated CNC. It's no longer using URI shortening services, and no open directories has been used in this case. And we also found that the threat actors in this campaign is mostly interested in the financial data. So we also found that they're using RAMPOST-RAT as a final payload to collect this information. So they are looking for bank, casino, money transfer sites, and cryptocurrency-related information in this campaign. We analyzed, in the first campaign, we analyzed a document file that was using template injection technique to download the next stage payload. So the technique works like that. The the injection technique, they are using a RTF file. The RTF file will have multiple Excel sheets embedded into itself. So it kind of shows multiple pop-ups to force the user or click on enable macro so that user can enable the macro and it will download next payload. The next payload in this case will be executable file. Again, it will be the executable file is having a PowerShell code that is in encrypted form, and then this PowerShell will download further payload. So the PowerShell will first disable Windows settings like Windows Defender, Windows Update, and then it will download second stage obfuscator PowerShell script from GitLab. So here it is using GitLab to download the PowerShell script. Okay, so finally the PowerShell script will download a PE file, that will be a .NET file, and the .NET file is using confuser obfuscator, and it will inject the Ozorot infostealer in another process. So the final payload will be downloaded from GitLab. Okay, with that, we are moving to our next case study, that is Edi Loader. It's also known as Goo Loader, and it was prevalent in the wild in starting of 2020. So here also the infection starts with a spam email, and we have seen that it's using malicious documents as an attachment, or there will be a link in the spam email from where an user can download a malicious macro. In that case, in this campaign, we saw that the malware authors are also using exploit, and they're using Google Drive, OneDrive to download the final payload. And in this case, they are also using multiple analysis, anti-analysis techniques to handle the analysis. So this is a flow diagram that explains like how the attack actually works. So user will first get a phishing email, then the target system will be exploited using malicious macro or exploit code that we mentioned. Then a malicious downloader will download a final payload. The final payload can steal the information from the system, and it will upload that information to CNC server. So this is how the overall attack chain is working in this campaign. The second instance that we saw, it was using a document RTF document file, and the actual sheet in that was leveraging CV 200 2017 8570 vulnerability. And in this case, it was using a SCT file that contains a hard-coded base64 URL. This URL will download initial PowerShell command, and it will be saved in the app data folder. Then it will execute this. Yeah, so in the second scenario, we saw that there was a malicious XLM file. There is a obfuscator macro used here. When the victim opens the Excel file, the macro code will automatically execute a PowerShell command here. So the PowerShell will download further payload in this case as well. Okay, so if we talk about the Edi Loader itself, the Edi Loader typically comes in VB6, VB file format, and it contains encrypted shellcode. So more than 70% of samples that we found belonging to Edi Loader were using Google Drive to download RAT and password stealer malwares. We have seen multiple well-known malware families where this particular malware was downloading families. For example, Netware RC, Agent Tesla, Ramco-Stat, Ozrot, Lockybot. So these kind of families we have observed in the wild. This downloader was downloading. So it is also using multiple anti-analysis technique. The first one is it try to enumerate all the open windows, and if the count is less than 12, it will terminate itself. In the second, it also checks for debug breakpoint API and some certain other APIs to verify whether it's being debugged or not. And it's also kind of detaching from the debugger using a undocumented thread information class known as thread hide from debugger using a NT-kernel API, that's NT set information thread. So before making a call to some API, it verifies whether there is any breakpoint set on this API code or not. This is how it's making sure that it's being debugged or not. And if it's being debugged, then it will not show full behavior. For encryption, it's using very simple encryption technique. So the final payload is encrypted using XOR, and the XOR key will be there in the file itself. And then depending on the configuration, it map or inject the final payload in the same process, or it will create a new process. Yeah, so coming to third case study, it's regarding AutoIt malware. We call it Frenchy AutoIt shellcode. And we observed this in December 2019. We saw a large number of AutoIt and .NET samples were being, downloading. We've seen that these were downloading multiple other malwares. The malware name was derived from the Frenchy shellcode, some mystic name. So this is how the malware name was derived. So this malware is using AES encryption for the final payload. Earlier we saw simple malware was using XOR or thing, but here it's using, this malware is using AES encryption. And similarly, it's also doing multiple anti-VM checks. It's using persistent mechanism, different persistent mechanisms. And most importantly, it's using shellcode to perform process injection, hollow process injection in this case. Okay, so the attack worked like that. So when we execute the first file, it will decrypt or extract the .NET compiled DLL binary file. This DLL file will again extract a ES encrypted resource, which will be a .NET compiled file. The .NET compiled executable file will perform multiple VM checks. First, it will check for a DLL name. If that is present, it will also check the caption of the main window. If the caption of the main window is empty, then it will not do further activities. And then finally, it extracts the shellcode that is responsible for injecting the final payload and making other changes. Okay, if you talk about the shellcode, so shellcode performs process solving injection, as we mentioned earlier. It uses anti-APIs like open section, map-BO section. This helps to bypass API monitoring that is done by this malware. It also creates the process in suspender mode and then create a new section and copies the main payload there. So we have seen multiple malwares, those were being dropped by this particular downloader. We have seen Agent Tesla, Darknet, Hawkeye, and Formbook like malwares. If we talk about the fourth case study, it is regarding Warlock. So we observed this starting in April 2020. Here also we saw that malicious documents were being used to deliver the final payload, and these documents were delivered through spam emails. We also observed that the attackers were using compromised WordPress sites to post the final payload. It was using different obfuscation techniques to avoid the machine learning based detections. Similarly, this was also using anti-sandbox techniques, and it was downloading URSNIF and ICID malwares. Those are well-known banking trojans. Okay, so in this case, the malicious macro, as we mentioned, is obfuscated, and the obfuscation is based on random dictionary words. So regarding the URL that is being used to download the final payload, it builds the URL at runtime using base64 encoding, reverse string, and split string techniques. The first payload is a DLL file in this one. So the macro will download a DLL file. The DLL file will be executed using Windows Bridge Server exe command. So this is how the DLL will be executed. The DLL will drop a JavaScript and temp file. So here multiple components as well. The JavaScript contains configuration data in itself. Along with the malicious list of URLs, there are legitimate domains as well. So this is just to hide the malicious traffic, CNC activity. It also do anti-sandbox check. It verifies the system uptime. It also iterates over all the CNC servers, the list that was mentioned in the config file, to download the next payload. So the next payload, it appends the CNC data. It sends the following information, for example, username, computer name, then user domain, uptime, and then ID. And when it gets the response will be base64 encoded. And to find the response, it uses a marker that we have mentioned in this slide. Okay. Further, it will get a JavaScript file. The JavaScript file will be written in the registry to hide itself. And then it also writes the same JavaScript code in a empty file with the .var extension. And the JavaScript code will be written in Active Directory stream. To execute the JavaScript, it will create a schedule task. And so this JavaScript will be run after some time. So this is how it's executing the JavaScript file. Okay, so if we talk about the CMC communication of the final payload here, or the final payload that is belonging to this downloader, so it sends different information that it collects from the system. For example, the bot ID, the plugin, it is also using different plugins, the plugin name, some random values, and then all this information is base64 encoded, and then it sends to the CNC server. Okay, so the fifth case study is regarding Remco threat. So here, the malware authors are taking advantage. They are using link file format, and we observed this campaign starting in mid-April 2020. It's also a multi-stage downloader. It's using patch and shell script combination. This one also is using AES encryption technique to hide, evade the security engines and to encrypt the final payload. Okay, so the attack works like that. So the link file will download the first stage batch file. The first stage batch file will create two schedule tasks or Windows tasks. The first one will lock the workstation using lock workstation API. And then the second schedule task will create a folder in app data. And then it will again download another batch script using cert Windows API. It will decrypt it and then run the batch file. Yeah, so again, this batch file, the newly downloaded batch file, it will launch the PowerShell. Here again, the PowerShell is used. The PowerShell will download two files. The one is final payload, that is EES encrypted, and a tool to decrypt this file. So this is a EEScript.exe. This is a tool to decrypt the file. And the password to decrypt this final payload is also in the command. So the password will be there. So it will decrypt the file, and then it will create another schedule task to run this final payload. So this is how the attack chain is working here. With this, I will be handing over to Avinash. Thank you.
Thank you so much. So moving forward, in our next case study, we have another downloader, which is based on link file type, and the malware name is Ashford Project. So this campaign started in mid 2019 and was specifically targeting Brazilian users. So by leveraging fileless execution and living off the land technique to evade the detection from the traditional antivirus tools. So it is basically using Google Cloud Storage to download the next stage payload using bits admin and certutil.exe, as well as using this window legitimate process rest service 32.exe to execute the payload. So this campaign basically starts with phishing email containing zip file as an attachment. The zip file contains the malicious link file. Once the user click on the malicious link file, and it leverages the WMIC tool to download the malicious XSL file from the Google Cloud Storage. So now this XSL file contains JavaScript code that downloads the final payload from the URL generated during the execution. So here v.txt file is our XSL file. So there are different functions in the script to generate a random number between minimum and maximum range provided as an argument. So now the way to build the part of the URL is that it generates a random number in the range of 7 times 1 to 7 times 9 and append it to the subdomain. And then it generates another random number in the range of 25,000 to 25,099 and uses it as a port number. So one of the function holds the random number from the range of 1 to 17, and corresponding to each number, there is a URL to download the final payload. So now the reason of generating these random numbers is to prevent detection from the network traffic, of course. So we have also noticed that the file are being downloaded using bitsadmin and certutil.exe, which are Windows binary. And also in order to not look too suspicious, file being downloaded with some well-known extensions like JPG and PNG, which also makes it difficult for a machine learning system to differentiate between malicious and legitimate program. So further, window legitimate process res server 32.exe is used to run the second stage malicious payload. So after downloading the next stage payload, file will be renamed with some random name, and then the binary is executed with the command line argument /kct/random number. So here we have observed that final payload is Gilma, which is well-known banker. So our next case study will be based on batch file, wherein a .NET binary, which itself has no malicious behavior and act just as a dropper, and this drops a batch file which is encrypted with base64 encoding. Now this batch file is having all the malicious code to download and executing the final payload. So first of all, .NET pad executable drops a batch file in temp folder and execute the batch file. So this batch file will disable the window defender and firewall. Then it uses certutil tool, which is again a window legitimate utility, to download the payload, and PowerShell is being used to execute the certutil. So after this, it tries to bypass UC, which is again a Windows security feature that enables a user to perform a limited number of admin operations. So which is bypassed by abusing the silent cleanup task to launch the scheduled task silent cleanup, and it would launch payload.exe with high authority. So yeah, so it also disables OneDrive to restrict all the available option for the file recovery in case of ransomware attack. So in this way, it disables all the security measures belonging before initiating the infection cycle, and especially disabling security measures regarding ransomware, so that the victim has no option left to recover the file from the ransomware encryption. And having said that, the final payload is ransomware, which is crisis ransomware. So yeah, moving on to the next case study, we have VBS file type, which is commonly being used as a downloader nowadays to download variety of advanced payload. And the interesting part here is that 50% of all the VBS based downloader logged in Zscaler's Cloud Sandbox were different variant of the same campaign. So in this case study, we have found that a campaign started in March 2019, where a VBS file being used as a downloader to download advanced payload. So the VBS code of this downloader contains junk data in form of comments, and the actual VBS code that downloads the final payload is encrypted. So now the actual downloader code is very simple. It where the URL is hard coded in the script itself, and it uses server XML HTTP ActiveS object for downloading payload, which is commonly used in VBS and VBA based downloader. So there is a dropper variant of this malware in which the payload is embedded in encrypted form in the code itself, and it uses create text file function to drop the file, and the command is also mentioned in the code itself to run the payload. So there were another variant where it was trying to download multiple URLs, as we have shown in the figure. Yeah. So now to mark the infection, this tries to create a shortcut in temp folder with different name, but this part of code is actually buggy. In some variant, the wrong path in the target path attribute is provided, and for some, the call to save function is incorrect. So, but due to the on error resume next statement, the script is working perfectly fine. So here, most of the time we have found that it is downloading Trickbot Banker, but there were some instances where it also downloaded Danabot Banker and Azerot password stealers. So we have our next case study on very prevalent malware campaign, which started back in late 2019. In this campaign, we have observed that cyber criminal mislead Portuguese user with the social engineering tricks in spamming mails related to finance and tax declarations. And once the victim, moving on to the next slide, please. So once the victim clicks on the link available in the spam mail and get redirected on the compromised server from where the first payload of the infection chain downloaded. So we have observed that for earlier variant, generally a zip file get downloaded which would contain three different files. One is PDF file, dummy file, and highly obfuscated malicious VBS file. So this VBS file is actually downloader is a downloader, and it also leverages Amazon Web Services to download the next stage payload. So, but in this variant, the attacker is leveraging a new trick where MSI file is used which contains malicious VBS file. So now, once the VBS file gets executed, the victim machine, it creates a link file for persistence and deletes all other previously presented link file. And it downloads two different files from AWS, as you can see, different AWS server, which is a log and UR. This is encrypted form. And yeah, so we have used decryption algorithm present in the malicious code itself to decrypt the URL, which is using Amazon AWS server. And finally, it will shut down the system with using window management. And the final payload will get executed by the link file created in the Windows startup folder during the first stage of infection. So as mentioned earlier, final payload being downloaded here is Lampion Trojan. And this is our final case study. We have is most commonly exploited file type, which is RTF. So here RTF.downloader, which is being used in another campaign by Gorgon Group targeting victim using spam email. And the email contains a malicious RTF document as attachment. In some cases, it also has the link file to download link to download the RTF file. So threat actor leverages very well-known exploits, which are CV 2017-199, that is DD exploit in the RTF file. So next slide. So now clicking on the link mentioned in the mail body, the user will be redirected to a shortened version of the actual URL using bit.ly.com, which serves as a malicious RTF file. So once the RTF file is opened, the exploits download an obfuscated PowerShell script from a particular URL, and obfuscated PowerShell script also downloads VBS file. Yeah, so that VBS file contains an obfuscated PowerShell script, which obfuscated using character replacement, that is 11 with @# classified code. And this PowerShell script is executed using WMI. So further, the VBS file creates a Windows scheduled task to run the script periodically, and copies itself to a location of temp folder with the .vbs extension. Now, to avoid the multiple installation on the same system, it checks the current execution path with the installation path mentioned. In the path, if the path is same, then it does not perform installation steps, and the PowerShell code downloads further payload and execute it. So final payload here is ngrat, which is being downloaded from an open directory, which also contains other advanced malware like RevengeRat and NanoBug, which is being used in the same attack campaign. So with this, I'm handing it over to Deepen to take it further.
Thank you, Nirmal and Avinash. Those were fascinating case studies. I'm going to conclude with some of the key points that I hope you guys were able to get from the case studies that were covered in the presentation. So one of the key thing that we saw is the adversaries are using several advanced mechanisms, and thing is they're using simple legitimate services, Windows legitimate services like search util, bits management, right? And the goal over there is, in combination with well-known scripting languages, it becomes very difficult for the security engines to differentiate between a script that is being written by a developer versus an actual malicious scripting file. They're also making use of several popular cloud service providers like AWS, OneDrive. They're actually malware families that are just designed to leverage things like Google Drive to save the next stage payloads and install it on the target system. Usage of these automation scripting languages also makes it easier for the bad guys to add new features, and this includes things like anti-analysis techniques, evasion techniques. If you guys noticed, the part that used to be embedded in the final payload, things like establishing persistence for the payload, things like disabling security software, all of those things are being moved in the downloader stage itself. And it could be second or third stage script that's performing some of these checks. But the goal of the attacker is disable security software, take all the actions necessary in order to ensure that the final payload is undetected. And we've been seeing multi-stage downloader payloads both in nation state as well as crimeware campaigns, and they're targeting several different industry verticals. So some of the campaigns that Nirmal and Avinash covered were fairly targeted in nature. All right. Well, with that, we'll wrap up this session. Thank you, everyone, for your time. Thank you. Bye.